Hello, I'm Richard Delgado, and today I'll be going through low mass star formation in a binary system. So, starting off, this is the grand scheme of things. I'll be going through this in depth, but just keep note that once we get to this white dwarf and red giant mixing image, that's when we're going to branch off into two different paths. So starting off, we have the protostar, which is the very beginning of a star's life cycle. The A protostar is a group of dense particles within a molecular cloud. Over time, gravity will compress the absorbed molecular cloud material into a ball, and as more material gathers, gravity will push down on it more, so it'll shrink. From there, the law of conservation of angular momentum will take over and it'll spin at a faster rate. Also, while it shrinks, the core will also get hotter. Over time, it'll get hot enough to where nuclear fusion will occur, and that's when you get your main sequence star. It maintains its size with equal gravitational pressure and which is inwards, and outwards pressure from the photons. So over time, the main sequence star will run out of hydrogen, which from there, gravity will become the greater pressure and it'll condense the star's core, which since all the hydrogen's gone, it is a mainly helium core, which it'll get hot, which will reignite nuclear fusion for the hydrogen surrounding the shell of the star's core. From there, it'll expand and cool. Once the red giant runs out of fusible materials and nuclear fusion stops, it'll become a white dwarf. White dwarf, excuse me, and it keeps its shape from degeneracy pressure. Essentially, gravity is continually pressing down on the white dwarf, but the electrons contained within the star are already too compact, and essentially they just push back enough to where it just doesn't shrink anymore. Um, Along with the formation of the white dwarf, the material on the outside of the red giant becomes ionized, and stellar winds blow the material away, making a planetary nebula, which is visible in the lower left corner. Here we have our white dwarf in the very center. So our topic is white dwarf in a binary system, which simply means a neighboring star. White dwarfs tend to be thieves, and they will steal mass from the neighboring star. Our white dwarf, we have our white dwarf over here. This is the mass that it is stealing. This is a red giant, what looks to be a red giant. Uh, so one of the two, this is where we branch off, and one of the two situations that it could occur is a nova, which is essentially the material that was gathered on the outside of the white dwarf heats up, and nuclear fusion occurs on the outer shell of the white dwarf, but it's an explosive nuclear fusion, and unfortunately pushes away all of its newly required material, but the white dwarf is intact, and over time the white dwarf will will burn out essentially, and become a black dwarf, which is just a black. It's the star's core with no luminosity to it, just the remnants of its heavier elements. There will be an image at the very end where I go back to my grand scheme graph. The other situation that could occur is a type 1a supernova, which, if the mass from the red giant is gathered too quickly, a white dwarf could grab more mass than it can hold on to, which that number is 1.4 solar masses, which also goes on the term of, excuse me, I might butcher this, but the Chandrasekhar limit. So if the white dwarf and its newly acquired mass goes over 1.4 solar masses, the weight will shrink the core, making it hotter, resulting in an intense level of nuclear fusion occurring all at once, which will cause a supernova, which completely destroys the white dwarf and leaves nothing behind. Here's a supernova, and that white dwarf is gone. So in closing, we'll go over a quick summary of what we just went over. Starting off, we have our protostar, and once the protostar heats up enough to where nuclear fusion occurs, you get a main sequence star. And once the main sequence star runs out of hydrogen, the main sequence star will become a red giant. Once the red giant runs out of helium, it will shrink into a white dwarf, with its shell getting blown away and forming a planetary nebula. Here's our white dwarf. The white dwarf and its neighboring star will cause two separate situations that could occur. It's always one or the other. Situation A has a nova occurring, which is where the white dwarf gathers enough mass but still stays within 1.4 solar masses, heats up enough to where nuclear fusion occurs, which causes a mini explosion, which pushes away all of its newly gathered materials and forces the white dwarf to just be back to what it was originally. If its neighboring star is pushed away from the nova, the white dwarf will become a black dwarf, which is just its core with no luminosity. And situation B has a type 1a supernova occurring, which is where the white dwarf gathered too much mass and sends it over 1.4 solar masses, which will cause the core to shrink, heat up, and essentially cause nuclear fusion to occur all at once around the star, causing a supernova. The supernova completely destroys the white dwarf. And that concludes my presentation. Thanks for listening.